All right, part 2 of chapter 1, and continuing with the scientific method. All right, this application of the scientific method can be seen in the discovery of the cause of ulcers. All right, so what causes ulcers? In terms of popular culture, maybe today, but especially 30 years ago. All right, what caused ulcers? It was stress. It was acidic food. And people were in a lot of pain because of stomach ulcers. And they would go to their doctor, and the doctor would say, well, change your career. Figure out what's stressful in your life and get rid of it. Eat a very bland diet. All right, but how can we know that that was the reason? All right. Did their symptoms change if they stopped doing anything, stopped working, and just relaxed all day? Maybe a little bit, but not completely. All right. Science is not about making observations alone. Rather, it's also coming to conclusions about mechanisms. What is actually going on within the experiment, within the system? All right, so the scientific method in action here are going to be observations. And these observations began to be made once doctors and scientists really started to think about the cause of ulcers, getting beyond the psychological component. All right, and what these observations were, many patients actually had a particular bacterium near their ulcers. So if doctors took a biopsy, a sampling of the lining of the stomach where the ulcer was, they could isolate a particular bacterium. So this led to a hypothesis. Helicobacter pylori is the cause of gastritis and ulcers. So experiments were, Helicobacter pylori was isolated and grown from ulcer patients, again taking those biopsy samples and washing them, and then taking some of that washing solution, putting it into broth, bacteria broth, or onto a petri dish. They could isolate the Helicobacter pylori. Second experiment, and then subsequent observations, was that humans who swallowed Helicobacter pylori resulted in having inflammation in their stomachs. And the interesting thing about this is the person who did this was actually a scientist. He was in charge of a group of scientists who was looking into the cause of Helicobacter pylori. And he simply took a small amount of the bacteria that was being grown in the lab and swallowed it. A few days later, he started having stomach pain. He then went on antibiotics to kill off the bacteria that was in his stomach that he put there intentionally, and he stopped having the pain that is associated with the Helicobacter pylori. So conclusion, Helicobacter pylori was the cause of most ulcers and can be cured by antibiotics. Actually kind of cool story, and he, I'm blanking on his name, but if you Google identification of cause of ulcers or something along those lines, you'll find his name, and he won a pretty prestigious prize, the Nobel Prize in Medicine, possibly. And this was back in the early 1990s. All right, so with a good experiment, you're going to have different variables. All right, you want to be able to control for things within your experiment. So you have experimental variable, which is the variable that is purposely changed or manipulated, and all other variables need to remain constant so that you can actually determine that what you are experimenting with is what is the cause if you see any differences. All right, then you have groups. You can have the test group, and that is the group of subjects that are exposed to the experimental variable. And then you have your control group, a group for comparison that is not exposed to the experimental variable. So, this in action, figure 1.9. All right, you have the hypothesis. All right, antibiotic B is a better treatment for ulcers than antibiotic A. And so what do you have? You split these people into groups, and you perform the experiment. All right, groups were treated the same except as noted. So the control group received a placebo. So maybe a sugar pill or a salt pill, something along those lines that had an inert material inside that capsule those people are taking. Group 1 received an antibiotic, or antibiotic A. Group 2 received antibiotic B. And then you collect the data and analyze for the presence of ulcers. And you have this GI doc who is scoping the GI tract of a patient to look for the presence of ulcers. All right, so percent treated, all right, with the ineffectiveness of treatment. Control group 10%, test group 1 had 60%, test group 2 had 80%. All right, so if we go back to this process of observation hypothesis, all right, and looking at this scientific method in action, you have the observations. The patients had Helicobacter pylori near their ulcer, and so you state the hypothesis that that organism causes ulcers. You have your experiment or your observations. Same thing, or same as we mentioned before. Helicobacter pylori was isolated and grown from ulcers, and then humans swallowing it develop the inflammation, and then you simply treat with antibiotics. So, all of that was followed within the scientific method. All right, another thing that you as humans need to be aware of is reading about scientific information. All right, scientific journals are considered the best source of information, but can actually be very difficult for the layperson to understand. All right, so if you pick up an article about zinc oxide nanoparticles and their effect on the antibacterial, bactericidal effect on Pseudomonas aeruginosa, are you going to have a clue of what they're talking about? All right, so you may not understand a whole lot of it, and if you don't understand it, right, you're not going to be able to have a clue of what's going on, to be able to process the information you're trying to read, to be able to understand it, to be able to pass it along to anybody else. So, often the layperson reads secondary sources, and therefore you must be wary of the information taken out of context. So you all have probably seen the different ads on television about different medications, and those ads sometimes might cite research information, or you see a news story. Right? That news story is going to pull some information from the primary literature up here and try to give it to you in a way that you can understand it. All right? That's not always the best way to go. All right? You should also be very careful about information on the internet. All right? So, using reliable sources such as websites that end in edu, .gov, .org. All right, sometimes those are legit, sometimes they are not. And what you also have to remember is thinking about biases. All right. All right, so what should you look for when you read about science? All right. You should not, you don't want to take the negative perspective, or I don't want to take the negative perspective. All right, but a lot of times the scientists who publish data, they're going to have an agenda or a bias, like I mentioned. when that individual writes about the science, that agenda or bias can come through. So you kind of skew the data a little bit to make it look like everything was successful, to fit what you wanted it to show. So when a scientist conducts research or gets to a point of publishing it, if it is just going into a newspaper, then what is its scientific value? What does the newspaper editor know about a particular scientific topic? All right, say ulcers. And therefore, how does she or he know if what is being proposed is correct? All right, for science to be more respected, it's typically going to need to be published in a peer-reviewed journal. That means that before publication, the work is sent to 2 or 3 other scientists who are very knowledgeable in the field, if not experts, and they comment on the science. Right? They say this was a good experiment. You had all the right controls, or this was awful science. You didn't have any controls. Why did you do this? Don't you know anything about this chemical reaction? There's no possible way for this to have occurred. All right? But if they approve, then the article is generally published or accepted for publication. All right, so you should be able to read a graph. All right, blood cholesterol over time. How does your blood cholesterol levels change? All right, what information does this graph line convey? All right, that in week 1, a person had an X value or a value of blood cholesterol somewhere around 187. All right, and that's going to be on the y-axis. This number is the y-axis. This is the x-axis. There's time on the x-axis, and then this is the data that was actually collected. All right, so week 1, cholesterol was at 187. At week 2, it was up to 212. At week 3, 200 down to 25, or 175, down 25 points by week 4. So what information is this trying to say? That the blood cholesterol went down? All right, you also have, when you're looking at scientific data, you want to look at the error bars. Right, those are these guys. All right, the error bars would actually almost show, besides this slight spike in the cholesterol from here to here, all right, the error actually overlaps each of these points, except for maybe this guy. All right, this value falls in the error of this value. This value point falls in the error, or has the error of this point that overlap. So there's really not a lot you can conclude about this graph. So science is a way of acquiring knowledge about the world. It is different than technology. And does science have social responsibilities? Yes. All right. As a scientist, I feel I have responsibilities to better science, to increase the knowledge base available, and to do no harm to the basic understanding of citizens. All right. So then technology is the application of the scientific method to human interests. All right. Bioethics is the branch of ethics concerned with the development and consequences of biological technology. All right. So there's genetic engineering. Is it all right to genetically modify crops? Does that alter the food quality? Does it alter the food or the product output? Is it okay to modify the product output if you don't modify the product itself? Or is it okay if you modify the outcome while also just slightly modifying the product? All right, so there's a lot of different questions that you can ask there. So bioethics is a field in itself. All right, then you have to think about human influence on ecosystems. All right, to modify ecosystems for their own purposes, good or bad, who knows? All right, and to think about emerging diseases, to think about climate change, global warming. What do we do